Section 9.2, nth roots and rational exponents. Evaluating nth roots. What we have is the square root symbol with a number underneath, and then we have a little number inside the hook called the index. And what this means is b to the nth power is going to equal a. If we have an even number as our index, the a, the number underneath, must be greater than or equal to 0. If we have an odd index, the number for a can be any real number, positive or negative. If no index is written, it is a square root, so the index is 2. An index of 3 is called a cube root. Higher indices are called by the number. For example, we have the 4th root of a, or the 5th root of a. It will be useful to have perfect values memorized and or know how to quickly find them. So some perfect squares and how you calculate them, some perfect cubes and how they're calculated, some perfect fourths and how they're calculated. Just as a side note, some of the values show up on multiple lists. For example, 64 is both a perfect cube and a perfect square. 81 and 16, those are both perfect squares and perfect fourths. So you want to make sure to pay attention to the index to figure out which type of radical we're working with. So to evaluate the cube root of 27, the cube root of 27, we're looking for what number multiplied by itself 3 times in a row equals 27, and the answer is 3. This is since 3 times 3 times 3 equals 27. The 4th root of 256, I have that one written up here, is 4. The cube root of negative 125 is negative 5. The 4th root of negative 16 is no solution because I can't have a negative with an even index. I can put that negative in front, however, it just carries down into the front of my answer. Scientific and graphing calculators do have a radical key on them. You look for a square root symbol. Some calculators will have a cube root. Others will just have an X spot in the index. And if they have a variable in the index, then you have to type the index value first. So if it's a cube root, you have to hit 3, and then this button, and then whatever was underneath it. Your keys may be above another button, in which case you need to push second or shift first. Or if you're on a phone or computer, you need the scientific view. On a graphing calculator, you want to look in the math menu. And so here's a few ones to do on the calculator just to make sure you know how to use your calculator correctly. Rounding to 2 decimal places, the square root of 15 comes up 3.87. The cube root of 17 comes up 2.57. And the 4th root of 53 comes up 2.70 after rounding. So you want to make sure that you can do these on the calculator and get the correct answer. Rational exponents. Rational means fraction. So I have my exponent is a fraction. What rational exponents mean is just another way of expressing a radical. So the denominator is the index, and the numerator is the exponent. So the exponent can be written underneath the radical or outside the radical. Just always make sure you simplify your fractions. And so we're going to evaluate if possible. And for starting, the easiest way to do these is to change to a radical. So 16 to the 1/2 power, instead of having the fraction 1/2, I'm going to change it to a radical. 16 goes underneath. The 2 is my index, but I don't have to write it because that's a square root. The 1 is my exponent, but you don't have to write an exponent of 1. So the 1/2 power is actually the same thing as the square root. The 1/3 power is going to be -8 underneath, 3 in my index, 1 as my exponent. So I have the cube root of -8, which is -2. So the 1/3 power is the same thing as the cube root. 125 to the 2/3 power. 3 is my index, 2 is my exponent. Solve the easier one first. I know the cube root of 125 is 5, and squaring that is 25. So when I said solve the easier one first, what I meant was, don't take 125 squared, it's way too big. Do the cube root and then square your answer. Letter D, -36 to the 3/2. Since there are no parentheses, the negative stays in the front. And then I have the square root of 36 to the 3rd power. The square root of 36 is 6. To the 3rd power is 216 with a negative sign still in front of it. -81 to the 1/2. No parentheses, so the negative just stays in front. So we have -9. Letter F does have parentheses, so my negative stays on my 81. Well, that's not possible. Oops, and G is the same as E, so we won't do that again. Working with those rational exponents, one important skill is to be able to rewrite from a radical to a rational exponent. So I want to have 9z in parentheses. My fraction, my exponent is 1, my index is 3, so it becomes 1/3. Part B, so I have in parentheses a cubed b over 7, and my exponent was 1, my index was 4, so my fraction is 1/4. Part C, x, my exponent is 3, my index is 5, so the fraction is 3/5. Part D, the 2 is in front, and then I have a to the 2/3. Part E, 24xy squared, so that all needs parentheses. My exponent is 4, my index is 3. And part F, we have n minus 3 to the 4/4. Simplify that fraction. We just have n minus 3.